Last one. This is Bernoulli. This is something that we have not really had a chance to play with, but I'm going to give you the opportunity to because it does really weird and very cool things. So, Bernoulli's principle, according to your concept tracker, says that you have to be able to explain it and what type of effect it has on buildings and structures like bridges. I love engineering, especially in standards terms. Bernoulli is pretty cool. You're supposed to do the Ed puzzle first. If you haven't done that yet, stop this video, go do the Ed puzzle. You need to log in using your Google, like whatever account you want to, and then I'm going to be able to give you credit because it's going to show me how you do and track your progress on watching the video. So please make sure that you've done that. It asks you to take a few notes in order to get that. So I'm going to go through and write down the things that you should be pulling out of the video as concepts that relate back to Bernoulli. All right, so here we go. Let's take a look at Bernoulli, or Bernoulli as they call it on the video. Bernoulli is awesome. What it says is that if you increase the velocity of a fluid, you decrease the pressure. Now you might be thinking to yourself, I don't get that. Let's draw a picture. Okay? Air is invisible. But let's pretend like you can see it. When you have air flowing, there's little particles like this. Okay? Now, we'll call this the slower air. If you end up taking something like a blow dryer and placing it here underneath the actual air and turning it on, what you're going to do is dramatically increase. You know how blow dryers have this on there. You're going to dramatically increase how fast the air is going. Okay? So what happens is you kind of blow all the air apart. Whoosh! You're blowing the air away. And so now it's going really fast. Sorry, I want to make this much slower. So you notice when air's not moving very fast, it's closer together. Okay? So the air molecules are much closer together. And that's the point here. They're not moving very fast. But when you blow them away, they kind of get spread out. Whew! Whew! There they go, getting spread out. But it's only in this area here. So you notice over here, you still have your air molecules all bunched up. Okay? So, what this does, actually, we want to go back and kind of label things here. Here we have, and I'm going to go back to using those symbols that I created, a big velocity. Here we have a smaller velocity. Over here we also have a smaller velocity. Okay, and again, that's how we're representing velocity. Put it here. And velocity is just nerd for speed. So let's put that in under here. Speed. Okay. So when your air moves fast, it gets blown apart and spread out. So you have this high velocity. It's going really fast. What Bernoulli says is when you make the velocity faster, the pressure goes down. Which means if we go back in here and we say, okay, now my pressure, because my velocity is high, pressure is just how many particles you have in each area. And the more particles, the higher the pressure. You notice here we have few particles, so we have a little pressure. But over here, we have a lot of particles bunched up, which means we have a bigger pressure. The same is true for here. This becomes really interesting when you place something in there, and we will do that. But this is how this all comes together. We have these pressures and these areas, and they will have different velocities if you make it like with a blow dryer or you cause it to flow somehow. So let's go back and make ourselves a little chart again. Our velocity relates not only to our area, but it also relates to our pressure in a very similar way as our area. When our velocity goes up, our pressure goes down. When our velocity goes down, our pressure goes up. And now over here you see that when your velocity goes up, your area is also sometimes smaller. So if you decrease your area, you can have a higher velocity. If you have a higher velocity, that means you have a lower pressure, which is very interesting. And that's because things are getting spread out. We're going to do a few little experiments with this. What we need to know is this piece here. All right, and I'm going to say it one more time because this is so important. I'm going to write it in blue. Velocity goes up, pressure goes down. When you have different pressures, so if you have a whole bunch of pressure here, and this is true of most things, and in fact, you all are probably feeling some pressure right now since you had this big exam. But if you have an area of a lot of pressure, very high pressure, densely packed molecules, everybody gets kind of stressed out, all these molecules sitting real close to each other. So what they do is they want to get away from each other and get some more space. They would love to go to a place of lower pressure, where there's more area for them, okay? And I like that many of you, when you were doing this, you were talking about the pressure. When you were talking about your fluid resistance, you wanted to talk about pressure, and that's really fantastic. We are talking about pressure, it's Bernoulli. But what these guys want to do is they want to go to a place where there's more room. So they actually, if you give them a path, start to flow. And when they do that, if this is in the air, this is actually how we get wind outside, okay? Or sometimes when you're standing in a doorway, you can feel a breeze, and it's because there's a higher pressure on one side of you and a lower pressure on the other. When you start to make your pressure, especially with air flow, you'll end up sometimes in the shower, and what will happen is your shower curtain. Let's see here. You know, have you ever been in the shower and your shower curtain starts to blow in on you? That's because the air particles are actually being pushed. They're pushing the shower curtain, so it pushes into the place where you have a lower pressure. If we go back up here, we can say, okay, if we have a low pressure, what do we know about the velocity? We have a higher velocity, all right? So let's put that in, higher. And then on the outside of the shower curtain, and you get your higher velocity when the water comes down, that makes the air flow, and that's when the curtain starts to blow towards you and stick to you. Over here, we have a low velocity, lower velocity, where the air is not flowing as much, okay? So there's another application of this. Not only do we have this blow dryer, but we also have that really annoying situation in the shower where the shower curtain keeps sticking to you, and that's because when you have two different pressures, this flow can cause things to move. If you can create this, this is how planes fly. You create a lower pressure above the wing, and then it starts, the higher pressure pushes your wing up. That was something that you saw in the Edpuzzle video on Bernoulli, as they called it. That is all that I have for those things. And we now have some beautiful and wonderful study guides that you can complete for yourself so that you can be studying these concepts. The really important thing is that you understand what the relationships are. So these little boxes that say, oh, I know velocity increases and pressure decreases. That's extremely important. I know velocity increases, that means that your area decreases. Sorry, this way. So these things are very, very important. And it's outside of the usual memorizing the definition, making sure that you know how to use Pascal's law or Pascal's principle, which is something I didn't even go over, but I feel like everybody has a good handle on that. So please study how to do your calculations as well. All right, that said, I am going to end this, and you are going to go and study. Good night.